Alrighty, in this video we are going to be talking about more on representing power series. This is going to be a supplement, which is not going to be in your packet. We have two more special series that you'll need to know that's really not covered here or in the packet, but Jason did mention it just in case that it shows up on the AP exam or something. 1 over x is going to be negative 1 to the n, x minus 1 to the n, and then ln of x is going to be very similar, where you have negative 1 to the n minus 1, x minus 1 to the n, but then you have an n right here. So that's just there for you to reference that. But our focus for today in this video is going to be on more on the power series that we did before we did the quiz. So we're going to go over a couple of, well, maybe all of these examples since they're all really good, and then see what happens there. Number 1 says, let f be the function given by f of x is equal to 1 over 2 plus x. What is the coefficient of x to the third in the Maclaurin series for f? So remember that here, the f of x is equal to 1 over 2 plus x looks like 1 over 1 minus x. So we are trying to figure out how can we make this look like this. What I'm going to do is divide everything by 2. And I get that. The only thing now I have left is just move that so that it's a minus, like that right there. Okay, so this is going to tell me that my summation from 0 to infinity is my first term, which is 1/2, and then my common ratio, which is negative x over 2 to the n. Now we know that because this is going to be a geometric series. We want to find the coefficient of x to the third. So essentially this is saying if n is 3, then what's my coefficient? That's going to be 1/2. Let's see. Negative x to the third, and then 2 to the third is 8. Which is going to give us negative 1 over 16 x to the third, which means that the coefficient of x to the third is negative 1 over 16. There you go. Yay. 2, let f prime of x be sine of x squared and f of 0 is equal to 0. Find the first 3 terms in the general term of f of x. Well, since sine of x looks like x minus x to the third over 3 factorial, x to the 5th over 5 factorial, ... negative 1 to the n, x to the 2n plus 1, 2n plus 1 factorial, and that is just regular sine of x. I'm going to build my function. In this case, I have sine of x squared. So now I have x minus x to the 6th over 3 factorial plus x to the 10 over 5 factorial. And that's going to give me my general term to be negative 1 to the n. And then since I have x squared, I am going to multiply the 2 and the 2n plus 1 to get 4n plus 2. So I have x, 4n plus 2, over 2n plus 1 factorial. And that's just sine x squared. Now that is f prime of x, the derivative. I want to find the original function, f of x. So what I'm going to do is go ahead and ignore my printer. What I'm going to do is take the antiderivative term by term. That's going to give me 1/3 x to the third minus 1/7 x to the 7th, 3 factorial, plus 1 over 11, x to the 11, 5 factorial, ... And remember the integrating and deriving power series lesson, where here I'm just going to up my power and then divide. So that's just going to give me negative 1 to the n, x to the 4n, up my power, so that's going to be 3, 2n plus 1 factorial, and then I'm going to divide, so that's going to be 4n plus 3. That's going to give me my general term of the antiderivative. Of course, we are going to have plus c. However, the plus c doesn't really matter in this case because f of 0 is equal to 0. So if I were to plug in 0 here, 0 here, 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 essentially, everything's going to be 0. So c is just 0 in this case, which means that my final answer would be this right here. Number 3, we want to go backwards. So if we're given this series right here, what's the function? Well, here's the thing. Out of my 4 special functions that I have, the only one that has n factorial at the bottom would be e to the x. Remember that e to the x looks like this right here. The only thing that we're missing right now is kind of the 2n and then the negative 1 to the n. Well, since I have a 2n right here, let's think about, okay, let's have e to the 2x. Well, if that's the case, that's not going to work because that's going to be 2x to the n over n factorial. I want the 2 to be an exponent. Because I have a 2 in the exponent, then I'm going to need x squared. That way, I have x squared to the n over n factorial, which is going to be x to the 2n. Okay, so that gives me this part right here. The only part I'm missing is the negative 1 to the n, which just makes my signs alternating. If I'm alternating signs, then let's have my series to be e to the negative x squared. That's going to give me negative x squared to the n over n factorial. Now, how is this the same thing as that? Well, what I can do is break up the negative x squared to the n to be negative 1 times x squared to the n over n factorial. Break that apart so that I have negative 1 to the n times x to the 2n over n factorial. That's how I get that right there. Yes, I'm kind of low-key speedrunning this just because it is 11:32. So, yay me. All right, number 4, we want to find the first 4 terms of the Maclaurin series for f of x is equal to e to the x over 1 minus x by multiplying each term. Now, even though this looks like a division problem, remember that I could take e to the x out so that we could see that this is technically e to the x times 1 over 1 minus x. Since both of these are special series that I can approximate, what I'm going to do is find the approximation for e to the x, and then find the approximation of 1 over 1 minus x, and then multiply them together term by term. Remember that e to the x is 1 plus x squared over 2 factorial plus x third 3 factorial. I am going to simplify this just because we are going to be multiplying soon. 1 over 1 minus x is going to be 1 plus x squared plus x to the third. And then I'm just going to stop there. Now, we want to find the first 4 terms. I'm going to be multiplying this by this. Now, the trick on doing this is looking at picking one of this series right here and multiply that by each term of the other representation. So what I'm going to do here is multiply each term here with e to the x. If I do 1 plus x squared plus x to the third with 1, I'm obviously just going to get the same thing. Okay. Now, if I were to do, let's say, 1 plus x squared plus x to the third times x, I'm going to get x plus x squared plus x to the third plus x to the fourth. Here's my problem. I don't really care about this. And the reason why is because I only want the first four terms. The first four terms are basically these four terms right here. So here, I could just stop at x to the third and call it a day. Anything above 3, we don't know her. She's trash. Delete that. Okay? So that's going to be this green right here. Now we have this pink. So now what I'm going to do is multiply what I have in blue with pink. So I have x squared over 2 plus x to the third over 2. Anything else, this is going to be x to the fourth, and this is going to be x to the fifth. Once again, I don't know her. She's trash. And then I have x to the third over 6, which is going to be in yellow. And that, I am just going to multiply that by 1. So that's going to be x to the third over 6 in yellow. Because anything else, that's going to be an exponent greater than 3, and we don't know her. Once you have everything, you're just going to add each column. So now you have 1 plus 2x plus x squared plus x squared plus x squared over 2. So this is 2x squared plus 1/2 x squared, which is 2.5, which is going to be 5/2 x squared. And then here we have 2x to the third, and then we have x to the third over 2, and then x to the third over 6. Let's see, 2x to the third plus x cubed. Put everything in denominators of 6. That's going to be 16x to the third over 6. Then if you simplify that, that's going to be 8 over 3 x to the third. So this right here will give you your first four terms of this series. Now, do we know the general term for this? No, and I really don't care about that because we're only going to be focusing on the first four terms and calling it a day. Number 5, this one's going to be new because we haven't really talked about dividing. So let's go ahead and do that. We want to find the Maclaurin series of degree 4 for f of x is equal to sine of x over 1 divided by 1 minus x by, once again, dividing. We know that sine of x looks like x minus x to the third over 3 factorial. And then 1 over 1 minus x looks like 1 plus x squared plus x to the third plus x to the fourth. Since this is a degree 4, I'm only going to do up to degree 4. Now with sine of x, even though you don't have a degree of 4, you are going to have to put placeholders because, and that's going to be inside. So we're going to have x minus 0x squared, or plus, I'm going to do plus for the sake of this, x to the third over 3 factorial, which I'm going to simplify to 6, plus 0x to the fourth. And then you have 1 over 1 minus x, that's just 1 plus x squared plus x to the third. And now this is just going to be your basic division. How many times can x go into 1? X time. So then I have x squared, x to the third, x to the fourth. Notice how it was important for us to have my placeholders, because if I did not, then you wouldn't know what this x squared would be, and you wouldn't know what this x to the fourth would be. I'm subtracting, so this is just going to be 0. That cancels out. So you're going to have negative x squared. And this right here, negative x to the third over 6 minus x to the third. This right here would be 6x to the third over 6. And if I am subtracting that, I am going to get negative 7x to the third over 6. And then minus x to the fourth. We're going to repeat this process with negative x squared. And since that's going to be with 1, we're going to have negative x squared right here. I'm going to do that in a different color. Let's see, negative x to the third, then negative x to the fourth. All right, so that just everything becomes positive now. So now that cancels out. Then you have this again, which is going to be negative x to the third over 6. Then that just becomes 0. That's okay. We have this right here with 1. So now I just have negative x to the third over 6. And then, of course, minus x to the fourth over 6. This is subtracting, so we're adding. So now I have x to the fourth over 6. X to the fourth over 6. And this right here would be my final answer of degree 4. Final answer. Last one, number 6, we want to find the first 4 terms in the general term for f of x is equal to e to the x plus e to the negative x over 2. E to the x is a special series that we know. And e to the negative x, we could build that. So remember that e to the x is just x to the n over n factorial. And then e to the negative x, it's just going to be negative x to the n over n factorial. All right, so if I were to list out the first couple of terms here, I'm going to have 1 plus x squared plus x to the third plus x to the fourth. I know I'm doing like 1, 2, 3, 4, 5 terms, but I do want you guys to see what's going to happen here. Oh, and I forgot my factorials. With the negative x to the n, I'm going to have, I am going to have negative 1, no, 1, just 1, minus x plus x squared over 2 factorial minus x to the third over 3 factorial plus x to the fourth over 4 factorial. Now, you'll see something special going on because notice how if we technically added these together, anytime we have an odd power, these two will cancel out, which is what's going to happen here because this cancels out and this cancels out. Well, I'm not going to have 4 terms now because now I technically have 2 and then I have 2x squared over 2 factorial and then 2x to the fourth over 4 factorial. And this isn't even me doing the divide by 2 yet. That's coming on later. So obviously our next term, if I were to make a little educated guess, would be 2x to the 6 over 6 factorial. Okay. Once I do that, I'm going to divide everything by 2 now, which means that, this cancels out, this cancels out, this cancels out, and this cancels out. Well, this becomes 1. And I get 1 plus x squared over 2 factorial plus x to the fourth over 4 factorial plus x to the 6 over 6 factorial, which is going to be my first 4 terms. To get my general term, Well, let's think about this. What's happening? I have x to the 2n over 2n factorial because I have I have even powers right here. So if I have 0 right here, x to the 0 is 1. If I have 1, term 1, that's going to be 2. Term 2, that's n is equal to 2, so that's going to be 4. 4 factorial. If n is 3, 6, 6 factorial. Now, how can I find this in relation to what I have right here? So here, remember that this is going to be x to the n over n factorial plus negative x to the n over n factorial, and then all over 2. Because that's going to be the same thing as x to the n plus negative x to the n over 2n factorial. Okay. Now, like I said, you might want to do a little bit of common sense in terms of thinking. Here, anytime I have an odd power, this thing will cancel out and become 0. So instead of me just doing x to the n plus negative x to the n, which doesn't really look like that, I'm going to have x to the 2n. Now, since I technically combined them because I have technically this right here, that means I'm going to have 2 x to the 2n. Just because if I have even powers, this negative is going to turn positive. So that means that I have x to the n plus x to the n, which is going to be 2x to the 2n, technically 2n just because we're dealing with even powers here. Okay, and then I have 2 times n factorial. So then the 2's will cancel out. So now I'm just left with, the n factorial also changes. So that becomes x to the 2n, and then this becomes 2n factorial. Because this technically depends on what these were, and since I said that they were even, this should also be even. And remember that the definition of an even number is 2n. So now I have x to the 2n over 2n factorial, which of course is the same thing like that. All right, I'm going to bed. Thursday, Friday, DECA kids. If you're watching this, good luck on your competition. Hope you qualify. If you don't, well, better luck next time. But I guess you could study for the test then.